In this video, we're addressing our second learning objective, solving equations involving a single trigonometric function. So as you can see, this equation right here says 2 multiplied by cosine theta minus 3 equals -5. So that's like our linear, almost linear equation. If we substituted cosine theta with x, it would be 2x minus 3 equals 5. A very simple equation. So we're going to start solving it the same as we would solve a linear equation. We're going to isolate our variable. And once we're done with that, then we're going to solve that resulting trigonometric equation. So let's do that. I'm going to copy it to cosine theta minus 3 equals -5. So how, if this was x, how would you solve this equation? Well, we would add 3 on both sides. So we would have 2 cosine theta equals -2. And then we would divide both sides by 2, right? If it was 2x equals -2. So cosine theta is -1. All right, so we solved our linear equation. Now we have to solve the trigonometric equation involving cosine. So where is cosine theta equals -1? Well, if we look at our unit circle again, there's only one angle on the unit circle where that happens. So theta is pi. So that's where cosine equals -1. Now, the question is, do we need to add circles on 360 degrees on top? Now, they restricted our solutions. They didn't tell us to find all the solutions. They only told us to find the solutions between 0 and 2 pi. And between, as I already mentioned, on the unit circle between 0 and 2 pi, there's only one such solution. So that's it. That will be our answer. So now go ahead and try it. So here's our example. It says solve exactly the following linear equation on the interval from 0 to 2 pi. So I want you to notice that it could be written in either in this way. This means theta is from 0 to 2 pi, and this is saying the same thing. So theta is from 0 to 2 pi. So it could be written in different ways, but I want you to understand that. Okay, so our equation here is 2 multiplied by sine x plus 1 equals 0. Go ahead and try it. Let's take a look at our next example, example 4, where we have 2 sine squared minus 1 equals 0. And again, our theta is between 0 and 2 pi. So again, if sine theta would be our variable x, that equation would be 2x squared minus 1 equals 0. And we know how to deal with this type of an equation. Since we don't have any x to the first power, we just isolate x squared. And then we're going to use this rule that says if k equals a squared, then we could tell that a is positive or negative root of k. I think it's called a square root property or something like that. So we're gonna first solve for sine squared theta. Just put everything else on the other side, and then we apply the square root property to finish solving it. Okay, so let's do that. Isolate the trig functions first. So adding 1 on both sides and dividing both sides by 2. Sine squared theta equals 1/2. So now what we're going to do, we're going to apply our square root property. So if sine squared is 1/2, that means that sine is positive or negative square root of 1/2. Now, what does that equal to? So we could actually separate the roots, and to rationalize the denominator, we would multiply the top and the bottom by the square root, and that will give us root of 2/2. And we know that, oh, and positive or negative root of 2/2. So if we look at our unit circle, where do we have a sine or a y value of square root of 2/2 or negative square root of 2/2? So we have two positive ones right here for angle pi/4. And then we have another one for 3 pi/4. And then we have negative ones down here. It's 5 pi/4, and also here 7 pi/4. So we're going to just list those values. And because, again, they restricted our domain for theta, it's from 0 to 2 pi, we are done here. We don't have to worry about 2 pi k. All right. In our next example, we have cosine theta equals -2. And they want us to find the solutions in the interval from 0 to 4 pi. So 2 circles around. Okay, so we know this value is already isolated. I mean, the trig function is already isolated. So what are we going to do about it? Well, what we're going to do, we're going to recall that cosecant, or is it? Yeah, cosecant is 1 divided by sine. So 1 divided by sine theta is -2. So what is sine theta? So sine theta, if we flip both sides, we're going to get -1/2. So again, this equation boils down to something that we already seen before. So sine theta is -1/2. Let's pull out our unit circle. So that's the angles of 7 pi/6 and 11 pi/6. Let's write it down. So we have theta is 7 pi/6 or 11 pi/6. But this is only in the interval from 0 to 2 pi, around the circle once. But our domain here is going around the circle twice. So we're going to call it 1 and 2, solutions 1 and 2. So theta 3, solution 3 is going to be 7 pi/6 plus 2 pi. That's going to be actually 19 pi/6. And our solution 4, we're going to take 11 pi/6 and add 2 pi on top of it as well. So we're going to get 23 pi over 6. So these two solutions are on our first circle around, and solutions 3 and 4 are in the second circle around. So these two are going to be from between 2 pi and 4 pi. Okay, and this is between 0 and 2 pi. All right. So now we can actually write the solutions, all of the solutions, list them. So solutions to this equation are, we have 7 pi over 6, 11 pi over 6, 19 pi over 6, and 23 pi over 6. So 4 solutions. Next, we're gonna look at example 6, which says tangent of theta minus pi over 2 equals 1. And our solutions should be in the interval between 0 and 2 pi. All right, so let's copy our problem. So for those of you, this format may look a little busy, right? So something's going on in parentheses, you know, it may look scary to some. So in order to simplify it visually, we could use a substitution for now. We could say, okay, this theta minus pi over 2, we're just gonna call it y. All right, so and instead of, so this is just one thing, this is the argument inside the tangent. So once we know what this is going to be equal to, we go from there. So for now, we're looking at tangent y equals 1. And that now this equation is not as complicated, right? So if we look at the tangent, at the unit circle, where does equals 1? Well, it happens in the first quadrant. I is pi over 4. I'm gonna keep writing it in a different color. Pi, or it's on the other side of the circle, 5 pi over 4. So that's where this equation works, right? But now let's recall that is actually theta minus pi over 2. So now we're going to replace our y's. We're going to put our theta minus pi over 2. And we're going to solve for theta. Okay, so add pi over 2 on both sides. So what are we going to get? This is 2 pi over 4, so 3 pi over 4. And on this side, again, adding pi over 2 on top of 5 pi over 4. We're going to theta equals 7 pi over 4, right? Yeah, 7 pi over 4. Okay. Now, our solution. So we have, are they in the range that they asked us, they provided us with? So the range is from 0 to 2 pi. All of these solutions are good. They're in the range. But what about other solutions? Are we going to have other solutions? Well, remember, is pi. period of tan x is pi. Okay, so when we add pi on top of 3 pi over 4, are we gonna be inside of this period? And the answer is yes, it's going to be 7 pi over 4, but we already have that listed as one of our solutions. What if we add pi on top of 7 pi over 4? So, I'm on the in the range that they gave us. Okay, so we're going to get 11. My internet got disconnected, so I don't know the last thing that you heard, but these are going to be our solutions. And let's see if we have anything else for this objective. Go ahead and try this problem. Says find all solutions for tangent x equals square root of 3. And notice that there is no restriction on the angle, so it could be anything. Plus, in addition to that, they told you to find all solutions. So you would have to find the pi k on top of the solutions that you find here. All right. Go ahead and pause here. So this is going to be our last example in this video. This video is getting long already. We have 2 tangent x plus 3 equals 5 plus tangent x, and the x is from 0 to 2 pi. So again, our first step is to isolate the variable. In this case, our variable is tangent x. So if you again, if this is too complicated for you, just to see it, you don't see it as a linear equation, then just make the substitution tangent x equals y. Then your equation becomes 2 multiplied by y plus 3 equals 5 plus y. So now it's a simple linear equation, but we're gonna keep our tangents, okay? So what I'm gonna do, I'm gonna factor 2 in, just like so. So 2 times tangent x plus 6 equals 5 plus tangent x. So now what we do, like what we will do here, subtract y from both sides. So I'm gonna subtract tangent x on both sides. So here, instead of 2 tangents, I'm gonna get just 1 tangent. Tangent x plus 6 equals 5. And finally, I'm gonna subtract 6 on both sides. I get negative 1. So tangent x equals negative 1. So remember that the period for tangent is pi. So we're looking for solutions from 0 to pi, and there is only one solution. That's 3 pi 3 pi over 4, right? If we were looking for all solutions, we would add pi k, right? That would give us all solutions. But for they asked us to find only solutions from 0 to 2 pi. So 3 pi over 4 is the solution from 0 to pi. Let's add one more pi. So when k equals 1, we're going to have x is 3 pi over 4 plus pi. And that will give us 7 pi over 4. So that's another solution. Okay, if we add another pi on top when k equals 2, let's try it. We're going to have 3 pi over 4 plus 2 pi. Then that will give us actually 11 pi over 4, and that's 11 pi over 4 is greater than 2 pi. So this is not in the interval, not in the given interval. So if we were to write down the solutions to this equation, we would write solutions to this equations are, and we would list 3 pi over 4 and 7 pi over 4. All right, that's it. Okay, and in the next video, we're going to look at how we can solve these equations using a calculator.